Hello, my name is Dakota, and
My name is Ryan.
today we are going to go over MP3, or constructing viable arguments and critical reasoning of others. Now, integration of MP3 into the Common Core standards, elementary students can construct arguments using concrete references such as objects, drawings, diagrams, and other actions. Students at all grades can listen or read the arguments of others. That's typically what they do in secondary education, higher level, because they can critically analyze all the material and all the problems and decide whether they make sense and ask useful questions to clarify or improve the arguments to make sure that they have a valid clarification statement.
Exactly, and that's going to be different depending on your grade level too. With elementary and then with secondary, it's going to be much different as to how you approach those processes. So specifically, the definition of MP3, when we're talking about this in practice, is mathematically proven students understand and use definitions, establish data, and stated conjectures in constructing viable arguments with reasoning purposes. Eventually, building progression within their data to discover the truth in their assumptions. They have the ability to break down problems and scenarios to provide falsification, leading to a conclusion that must be justified, corroborated, and interaction in others' arguments. That's essentially a very long way of talking about how students are going to break down these problems as opposed to just following a process, why they follow the process, how they understand how that works, if they can come up with falsifications as to why other ways would not work. Basically, this is just building up their argument and critical thinking skills.
Very good, Ryan. Now, I'm going to go over 2 examples of elementary. These are the most common used in 1st through 4th grade. So what we're going to start out with is a word problem. Meredith gives Christopher 10 Hershey's Kisses. Meredith gives Henry 4 Hershey's Kisses. How many Hershey's Kisses did Meredith give away? How many Hershey's Kisses does Christopher have than Henry? How more does Christopher have than Henry? Now, what you want to do is you want to write out your variables as you listen to them. So start out with 10. And if you want to label it, you can use Chris, and then 4 for Henry. Now, those are the variables. Now, what we start out with is the first proportion of the problem. How many Hershey's Kisses did Meredith give away? Simple. All you have to do is just add an addition symbol. Now, how many more kisses did Christopher have than Henry? Simple. That's all you have to do. Now, with larger numbers can be more difficult, but also doable. So in 5th grade, they do problems such as, say if your grandma made 86 cookies. She gave Betty 50 of them. So you start out with 86 minus 50. How many cookies does she have? So all you would have to do is 36. Now, out of those 36 cookies, she gave Micah 15 more. So all you would have to do, 15 equals, it is 21. And you just repeat the process over and over and over. So first, you would separate the equations. That is what they explained at the end of the problem. Subtraction and addition using the word problem. When you complete step 1, what the class will typically do is share the problems with one another. As they share the problems with one another, they will use reasoning and argumentative skills. Argumentative as in, if someone got the wrong answer, they're going to try and figure out how they got the wrong answer to fix it and correct it so they can all be on the same page, rather than argue that I have the right answer, I have the wrong answer, so on and so forth. Now, what we're going to do is we're going to have Ryan go over the high school level problem.
Higher level. Exactly. When we approach advanced high school, college, peer-related problems, you're going to be going over a few more advanced concepts. One of those being surface area. Specifically, we're going to be talking today about surface area of a rectangular prism. So say we wanted to give a group of high school students, break up into groups, and have them solve this problem. That's easy enough to do if, at that point, they have the skills available to them to deal with equations and things of that nature. So if we were to solve this problem, we would just stick in our information we have for the variables into the equation. So here we would have 6 times 4 for the width times the length. We would have 2 times 4 for the height times the length. And we would have 2 times 6 for the height times the width. So if we solve this, we'll have 24 plus 8 plus 12. And if we add these together to 24 plus 20, that gets us 44. But that was just what we had in our brackets, or in our parentheses. So if we multiply 44 times 2, we know that the area of this rectangular prism is 88 centimeters. So that's all well and good, but we're trying to get them to defend their answer and how they got to this problem. There's a couple things we could do for them. And this is where, when you have the students break into groups, they would have to explain their answer further. And so that once they get a justification, they'd be able to discuss with their peers as to why this works. An example of something a student could do is to take this shape and unfold it, essentially. They could draw that here as well. If you unfold a rectangular prism, you get it to look like an unfolded cardboard box. Real-world application that can get students thinking about it, as opposed to just these vague mathematical concepts floating around in their head. So when we have it looking like this, we can start to see, or students can start to see and justify as to why this formula for the area of a rectangular prism works. They can see that they're taking the normal area of these rectangles, each individual rectangle, once. So we have one rectangle here, a different size rectangle here, and another here. Then they can look and see that they need each of those twice. Why do they need each of those twice? Because when you look at the unfolded box, you see each box repeat itself twice. We see 2 of those rectangles. We see 2 of these rectangles, and we see 2 of these rectangles.
So you're essentially duplicating the sides.
Exactly. And in duplicating the sides, you can see that written out here in this formula. Getting students to understand formulas and being able to see the processes and concrete examples really helps them understand. And if someone can defend their arguments or why something works, that's when they know they have a true understanding of that process.
Awesome, that is very good. That was a very good explanation by Ryan. Now, the goals. The goals of this, the students can defend their reasoning and develop logical reasoning and argument skills. They are also good at using formulas as a basis for these arguments, so they should be able to use relation to a lot of this, all of it. That pertains to the matter at hand and the problem that they are trying to solve. A function that is explained, explanation is key with everything. Now, the teacher can help them construct concrete arguments when needed. We should be able to utilize our tools to help them succeed and be able to use their critical thinking and problem solving skills with arguments, so we can collaboratively use these together.
Exactly. Like I was saying before in that problem as well, the different strategies you could use that peer system where you break them into groups, have them try and defend something, and then come and discuss with their peers, both elaborating on their critical thinking and argument skills. As well, for the assessment, you could use how the students present their arguments, how they could use falsifications to show why other things wouldn't work, how well prepared they are to discuss with their other groups, and how they adapt as the conversation progresses.
And Like I said, everything that we needed was diagrams, actions, objects, and other portions of symbols that can actually help the student understand the problem. That is elementary because they don't have a full understanding of word problems, for example. So these arguments make more sense because they are not validated.
Exactly. And then when they get older, they'll be able to listen and analyze others' arguments. They'll be able to create a hypothesis on whether or not an argument is valid or invalid, and they can use investigation methods to understand and help their reasoning of arguments. So we hope that helps you better understand MP3 of the Common Core. Thank you.
Thank you.